We something came up and we couldn't hold the session for last week. But we are here today again to kick off this wonderful session. And our speaker today is Mr. Ebube, and he's a Java enthusiast, a passionate Java person. I mean, I've worked with him, so I know the depth he gets, and I've learned a lot from him. Get so um, as we open our hand and heart to get, but yeah, definitely we'll be kicking off with an introduction to Stack, and Stack is something very important. Let me just give a brief. So Stack memory. Stack is very important as a program. It helps you understand how your method works, and it helps you in certain other areas where you want to implement some complex data collection stuff. So I believe this particular session will be giving us an intro into what Stack is. So we don't call it stick. It's not stick. I was in an interview and they had to correct me that it's not stick, it is stack. I think I lost that job, sure. But we can't get for it. So, yeah, Mr. Ebube, you have the floor, sir.
Good evening, everyone. Um, a quick disclaimer. I'm sure if you saw the flyer for this session, you'd have seen a picture of Mr. Jonathan, our boss, but he was unavoidably unavailable, so I had to step in. But by God's grace, I'll be able to do it justice, just like he would have. Okay, so introduction to stacks. Stacks are a very important linear data structure. So it's still a linear data structure, like your arrays or your queues. So there are two main ways to implement stack. Um, you either use an array or a linked list. So that was why we started with, if you have been following the DSA sessions, we started by introducing arrays first, then linked lists, and now stacks. Because arrays and linked lists they serve as the building blocks for many other data structures. So it's very important you already have an idea of how arrays and linked lists work. Okay, so the main property, the main thing you know about stacks is that they're a life data structure that is last in, first out. Uh, a way to think of it is by thinking of a stack of plates now. For those of us bachelors that still wash plates, if you are stacking plates, you put the first one under, then the next one, then the last one you put on top. And if you are not a psychopath, if you are a normal person, if you want to carry those plates, you first take the one on top, which was the last one you put. So last in, first out, life data structure. Okay, then yeah, like I said, there are two main ways you implement them. You either use an array or linked lists. Both linked lists are preferred. And if you remember, the main benefits of arrays is when you are looking up items by index, since it takes constant time. But arrays are bad when you have to keep adding or deleting items, because you have to have a copy or a resize operation in it if the array is full. But with linked lists, you can easily add or remove items. If you have a doubly linked list, it will even be easier to delete items. So it is usually, most of the time, you see queues being stacks being implemented with linked lists, because you hardly have to query a stack. Stacks have three main operations: peep, pop, and push. Some languages have different naming conventions for some of them, but that's basically the idea. You are either pushing an item onto the stack. You are popping an item off the stack that's removed in the last item, or you are picking an item. That's basically you're asking the stack to tell you what item is on top without removing it. So those are the three main operations. So you hardly ever have an operation like find or get me the index of this thing. So that's why, like, since you don't really have to iterate over the stack, it's better to just use a linked list since most of the operations are push and pop. Okay, so the the runtime complexity for the push and pop operation is of one. Since like those are most of the time that's daily operation you're going to support. So you're just pushing an item onto the stack. You don't need to do any resizing. It's just basically you adding a plate to another pile of plates. And if you want to remove it, you quickly remove one. So it doesn't support, you can't take out an item out from the middle, out from the front. No, you're usually just taking an item from the top. That's the last item. So, one. And stacks are used in a number of places. The most important one I can think of from the top of my head is in computer memory. If you've ever had something called stack overflow, that's the part of virtual memory. If you have heard of stack and the heap, so that part of virtual memory that we call the stack, where you have functions being pushed, where you have functions being pushed on as stack frames and local variables. That is actually implemented as a stack. So the last function to be pushed onto the stack is the one that will be run, and then once it's done, it should be popped off the stack. So you still have, do not anymore. There's a common misconception, but not anymore. But you used to have stacks being used for undo video operations, traversing your browser history, but not anymore, because if you notice, like if you are doing undo video like in any text editor, it's actually quite more complex. It's more feature rich, like depending on the text editor you're using. If you're using something like Emacs or IntelliJ or Vim, like you can go back a number of times. You won't have branches in it, so they tend to be implemented now with non-linear data structures. So depending on how the text editor is implemented, so they may be using ropes, they may be using gap buffers. So they tend to use more advanced data structures, not stacks. But if you're doing something very basic where you need an undo video operation, stack is a nice fit to have. Another place where stacks are very, very useful, as we will see, is in reversing items. So let's say you have a list of things and you want to quickly reverse it. One of the best ways to do it is to iterate over each item, add it, push it onto a stack, and then pop out each item into a new or the same array, and you have automatically reversed everything. So it's a very nice, clean, easy to think about your reversing items, and you tend to see it's being used a lot. Stacks are also used to implement some other larger, more complex data structures. So it's it's a very essential topic you need to know if you are trying to implement your own custom algorithm to solve a particular problem. Knowing about stacks is something you want to have in your tool builds. So again, the pop operation removes the top elements, and like it removes it, so it returns the first element from the last elements you push onto the stack, and then returns it, so it's removed. I don't see the implementation now. So here I'll show you an example. Yeah. Format this stuff nicely. So here we are pushing an item onto the stack. Let me do it linearly. 1, 2, 3, 4, 5. I think I implemented a way to like print die. Did not. Okay, so we are pushing an item 1, 2, 3, 4, 5 onto the stack. So the last element we are pushing is 5. So if we were to call the stack.pop operation, so hold on, I think I have a syntax here somewhere. Okay. So again, if we were to check the last elements that was popped out of the stack, it would be 5. So again, so those are the main thing you should know is the difference between pop and I think it's called peep, yeah, pop and peep. Like okay, if we were to have, let me just something more. Oops. Right, borders, peeps. Yeah. Forgive the naming this thing I'm using. Like most people, I struggle when it comes to naming things. Yeah, pops. This. Okay, so ideally now we are popping out 5. So our stack should look something like this after popping it out. 1, 2, 3, 4. So 5 is no longer there. Then we're calling heap. So we will still get 4, which is the last element, but after calling it, our stack will still look like this. So you see 5 and 4. I think a better way to show this would be to reverse this. So I'll peep the item first, then pop it out. So when we peep it, we'll get 5. When we pop it, we'll still get 5 because the peak operation doesn't remove the last element. Just basically just like you're picking at it, you're just checking what's there without actually doing any delete operation. Yeah, around this. Again, we get 5 and 5 because the peep operation, like I said, doesn't remove any elements. Okay, those stacks don't really take much time to implement, but I'm not really sure I can do it like off the bat and still keep things interesting. Okay, so we'll just go over the implementation without me writing it myself because I've already written it before. Okay, so okay, back to the slides. So I've covered pops and peeps. Okay, yeah, you tend to see not all, but I think most languages have an isEmpty. isEmpty is like, yeah, most languages have isEmpty, but not all tend to have the size operation. Well, they are also common. There are 3 basic operations: pick, pop, and push. But most languages support isEmpty operations because you tend to use them when you want to use a stack to implement an algorithm. Like if you're reversing a string now using a stack, you'd need to, don't even see the implementation, you'd need to check that the thing is empty so you don't pop something that is not there and don't get the null pointer exception. But Contrary to what you may think, you don't really have to um, you don't have to iterate over the stack. So you can just keep a variable or a field called size and increment it as you push items onto the stack and decrement it as you pop items. So the size and the isEmpty operations will just be returning fields and you would get an O of one operation. So again, you don't have to iterate over anything. You just store them in memory, then increments and decrements as you push and pop items off the stack. Then we will look at the implementation of my code. I think we should just go to the implementation now. Okay, so I don't really have a count element, but you can see here, I'm using an array to implement the stack. So internally, like I said, you can either use an array or a linked list. Linked lists are preferred because you get O of one deletions and insertions. While in an array, depending on whether it's full or not, you may have to resize, which now become an O of n operation. So, but it really depends on what you want to do with the stack. But most of the time, use a linked list. But for the sake of simplicity, and I don't think we have covered linked list yet, so I'm using an array. Okay, so we have an array of items. That's what we basically use to store the items because every single thing you're pushing has to be stored somewhere in memory. So we're using an array to keep track of the items. So let's look at the first operation. You can pop. The first operation that you really have to implement is the isEmpty operation because we'll come back to it. Why the isEmpty operation is the first thing you want to implement. But here, because I'm using an array already, I already have access to the array's internal .length operation. So here, I'm just checking if the length is 0. And I think I implemented this array myself, did I? You know, I'm using Java, not the one I implemented myself. So if we're not using an array, we're using something else, then we may have to have a custom field here. Let's say something like counts, and we'll initialize it to 0. Like that. And we'll initialize count to 0. Then in the isEmpty, we'll just basically return the counts. Then whenever we have a push operation, we would basically do counts plus basically implement it. So if I like to do that, I rather do it an easy way of using the items.length operation. So yeah, then this operation will now basically be return counts equal to 0. So I'm just basically returning the expression whether count is equal to 0, meaning whether it's empty. Yeah. So this is another way you can implement it if you want to do things more manually. Okay, so again, so that's the first one now, this isEmpty operation. The reason why you want to do that first is that, okay, let's say you initialize a stack now, you just created a new stack, and then for some weird reason, you want to start popping items when you have not inserted anything inside. If you don't have the isEmpty operation, you will not be able to check whether it's empty. So let's come to that now. So if isEmpty, let's choose a new, is it illegal states? I believe it is called illegal states exception. Say something like stack is empty. Yeah, so we try and we ask the exception. So that's why the isEmpty is like one of the first things you want to implement first. So if someone is, oh good, I made a mistake. and to do this in the pop operation. Sorry. So if someone is popping an item when the stack is empty, would show this legal state exception. Then we now have our push operation. So like I said, push is very easy. We're either using an array, so we're using the arrays insert method. If this was a linked list, it will basically be the same thing. It will be an add method instead. So we're just adding an item to the array or the. Let me just use the generic term. Like we're just adding the elements to the list. That's all. Then incrementing the counts. That's all. Like you can make it more complex if you want, but like basic stack, this is just all you need to do. Then the pop operation now, removing an item. Okay, because we are using an array, it's a little bit more verbose, because if we were doing something like let me just say, if we're using we're using a linked list now, they have a method to remove the last item automatically. So we just have to call that. But because we're using an array now, we have to do things more manually. So here I'm getting the last index of the array. Remember, array start at 0. So the last element will be the length of the array minus 1. Then I'm now getting the item at the last listen. It's Java. I just see this one. So they have an item at method. Is this mine? See, I'm just showing this is the implementation of the array.item at method. So you're just getting the item at a particular index, and this is just all this thing behind the scene. That's all. You're just doing it how you'd have normally done it, but now you now have this nice bound checking inside. So that's why it's good to use the methods that they provide you. So then once you have gotten the last item from the array, you simply remove it using the remove method. Let's look at the implementation. Again, we're calling a shift operation here. And documenting the counts. If you watched the DSA session about arrays, nothing here should be new. So then again, we return the item, that's all. So it's just giving them the last item. Nothing hard about that. But in peak now, I should also add this isEmpty method to the peak. So again, for the peak operation, we check if it's empty. If it's empty, we try the legal state exception, saying the stack is empty. If it's not, then we just return the item. But we don't do any shift operation. We don't delete it. There's no remove at method. So yeah, that's basically all. Okay, I guess it's dot size operation. Let's just write one quickly now. That's size. That's all. We are done. We're just returning the counts. So let's test this now. Let's not pop any item. Document. Oh, this out. Start the size. So to print out 5 right here. Yeah, so now let's look at some useful things that you can use stacks for. They used to ask it like all these interview questions, but I don't know if they still ask it now. Since everybody already knows how to do it now, maybe they'll ask how that ones, So like I said, reversing an item, let's look at the implementation of this. So like I said, whenever you want to reverse something, maybe it's a list of items, so you just want to quickly reverse something, a stack is a really nice way to do it. So here we have I'm defining the method on the stack class itself for the sake of simplicity. So again, we initialize the stack. That's what we're going to use to temporarily store the items. To reverse them, then we initialize the builder class. If you are wondering why we want to use the builder class, it's because strings in Java are immutable. So you can't do append operations to it. There's a reason why they are immutable as well. I don't know. Should I talk about it here? Yeah, immutable, like you can set it to null, which is strange, Java. Okay, so we iterate through the string, we convert it to a character array because strings in Java, unlike C, are not basic, they're not character arrays. Like if you have done C, you know that strings in C are just basically an array of characters, but not C in Java. It's like a custom class with other methods and small safeguarding built into it. So we first need to convert it into a character array using the toChar method. Then we're using a for each loop. So S will be set to each character. Then we're now pushing it onto the stack. So we're going to each character, pushing it onto a stack. Then to now reverse it now. We're now saying while the stack is not empty, pop out the last element from the stack, which will actually now be the last element now will actually be the first, and put it back into the builder system, the builder method. So yeah. So again, the user passes in a string, we convert it to a char array, we then iterate through the character array, pushing each item into a stack. Hopefully the code is very straightforward. Then as we're popping out the last ones, the stack is we're done iterating this thing. While the stack is not empty, we keep popping out items and appending it into a new array. Let me use small illustrations so that you guys will see. So let's say our string here is, let's say the string is word. Let's say the string is word. So what we are pushing the stack now. The stack will now basically have be word to. This is what the stack contains. So we're iterating to W, adding it into the stack, iterating to also get push it onto the stack, push it onto the stack, D push it onto the stack. Then yeah. So at this point, this is basically what we have in our stack. Now our builder method, string builder class is empty. Let's just call builder is empty at first. Then we're now popping out the last item. So the end is basically what we have. Let me just bring this here. So we can only pop out the last item. So the last item here is D. We're now popping it, appending it into the distance first, popping out the last one, adding it, popping out the last one, adding it, popping out the last one, adding it. Then at the end of the day, we convert the builder method, which is just basically a buffer in memory, and convert it to a string object, then return it. So now we have the word reversed. So again, let's test it. All I use stack dot what I call string reversed. This is my name. Oh no, my name is actually a palindrome. So if I were to type Ebube, you still get a. Let me use something else. Uh, let me use some. I guess. Oh good. Okay. So on some I didn't print anything else. I'm supposed to wrap this to a. So versus Samuel. If I were to use Ebube, it still gets Ebube because my name is a palindrome. Okay, so one other tricky popular interview question before is checking whether a string is balanced. I don't know if you've read any or if you watched any DSA tutorial back then and when tech was still hot, you'd have seen this question before. So the idea is basically that VS Code. This is why intelligence is always better now. VS Code uses the lecture. So by the time you have many extensions loaded, it just become slow. It just become very, very slow. Because this thing is just basically a Chromium browser and a Node.js backend together. If we were to check now, this thing probably be using 1 gig of RAM. It's not even the bloat size, but like it's like IntelliJ now is way larger than VS Code, but it doesn't have all these issues that VS Code has. It doesn't get slow. Sure. Oh, you do. Okay, so the basic item is that you are given a string now. Let's see. And you're not to check if this thing is balanced. Basically, if the number of opening brackets match the number of closed brackets, and they have to be of the same type, like here now, this string is balanced because I have an opening brace here, no corresponding closing brace. This is the normal square brackets. This part is balanced, but this is not balanced, so you return false. And wait, let me just copy this. Okay, please go do this again. But this is balanced. Let me just. Yeah, but this is balanced because you have a corresponding brace. I wish I could have done this in life. It's actually very fun. But we'll just go through the implementation because of time. Okay, so this code is very sweet. So the logic reads so clearly. So we're initializing a new stack. So we're using a stack to solve this particular problem. So to implement this algorithm. So we get a new stack object. Then we now iterate through the string parameter. We convert to a array because, like I said, strings in Java are not arrays, they are objects. We first need to convert them to a character array. We convert it to a character array, use it for it to look to everything. Now, so let's say our string is what's the best way to check? Let's say our string is, let's use some of it, yeah. This is our string. Samuel. Well, this counts as a brace.
Okay, I'm with you. Sorry. Are you calling me?
No. I'm just using your name.
Hello?
I'm just using your name. Are you following? Okay, so this part counts as a brace too. So this is basically not balanced because you have a closing angle brackets, but there's no opening angle brackets. So again, so we're looping through each item in string. So first of all, we have the opening brackets. We now push that onto the stack. Then, so we'll push the, if it's a left brackets, so basically left brackets would be, left brackets would just basically be, so yeah, so all these things now are left brackets. And left brackets would be, what is this? So, and this will be right bracket. So if it's a left bracket, we push it onto the stack. So at this stage now, our stack contains this. Oh, this is our stack contains the first opening bracket. We have first left brackets, this. So else, if this was a right bracket, we first of all check if the stack is empty. If the stack is empty, we just return false. Like, because basically, okay, why we have that logic here is because if we have something like, if we have something like this now, so this is not balanced. It has to be opening and closing. So this is not balanced. So if the first item we get is a right break, so the stack is empty, and the first item is a right bracket, we just click my return false. It's not balanced. So that's why we have that logic there. So again, but if so now our stack is this now. We check is it left brackets. Our stack now contains it, we push it onto the stack. We go to the next element. Skip. So let me delete this so it doesn't confuse us. So skip. We come to this, is a right brackets. So we enter this logic flow. Is the stack empty? No, the stack is not empty, so we can return false. Then we now come here. We now pop out the left brackets. So at this point now, the left bracket variable basically contains that first left brackets. So it basically contains this. What was in our stack before, because we just popped it out. Now we're not checking if this left bracket matches the right brackets. So we're saying if this bracket does not match the left brackets and the current character C is current character C, basically this at this point, So we check if they match. Also, if they don't, this is an angle bracket. This is a curly brace bracket. So return false is unbalanced. So yeah, that's basically how the logic works. So that's like, but like, you know, I have to implement these methods myself. So this basically was the final methods like. So VS Code is moving by itself. I'm not even touching it. That's how slow the lecture is. Okay, so if we are now going to have, if we take this away, now. First item, push it onto the stack because the left brackets. With this, we'll skip this because there are no brackets. We now come to this item. Is the left bracket? No. Is the right bracket? Yes. The stack empty? No, because we have this inside. At this point, C now contains the last element. This. We now check if they match. They do match. This not operator does not flip it. So we come to the very, very end. So we now return if the stack is empty. We don't return true here. And the reason is that you might still have, okay, let me just, if we had an extra item now, let's say we had an extra item, the stack has to be empty. Let's say we had this now. So in that last one, we would have returned true. It was balanced because the stack would be empty because we just put this out. But now let's go through this condition now. Again, first element is a bracket. Yes, is a left bracket. We push it onto the stack, come out of the flow, go to the next character. We skip this, we skip this, we skip this. We come all the way to this one. Then, is it a left bracket? No. Is it a right bracket? Yes, it is. The stack empty. No, the stack contains our first left brackets. Then we pop that out from the stack. So our parent character is this, the closing brackets. Then our left brackets together. We check if they match. They do match. Now, then we now return. Then we now, again, we're not done iterating to the array. We now come again to the last item. So at this point now, our stack is now empty. Because once we reach here, we have to pop out one item. Remember, pop removes the last element. So our stack is now empty. We now iterate now to the last item over here. Is it the left bracket? No, it's the right bracket. Yes, it is. It's stack empty. Yes, the stack is empty. So we now basically return false. So it's not balanced. So that's why we have to use the check rather than just returning true. Okay, so again, you have to implement all these methods yourself. Or like we could have written this into a very, very huge function. So if you have read clean code or any refactoring group, you hear the advice, functions should be small and do only one thing. So all this does is checks if the thing is balanced. And we have little helper functions like is it the left bracket, is it the right bracket, if the brackets match. So let's test this, then we'll call it a day. Yeah, let's use that sample example. So this should print true. This should print false. True. False. And oh good, I'm not going. Look at me, I'm not going back on this whole thing inside the method itself. Hold on. So just be able to very quickly. Okay, so she gets true, false, false, false. And we do. So there are many other things you can do, many other algorithms. Yeah, you can use stacks you can only use a stack to implement a queue. A queue is like the opposite of a stack. While a stack is a LIFO data structure, a queue is a is it FIFA, FIFO? First in, first out data structure. So we have covered all the implementation detail. Again, you can use either an array or a linked list. Yeah. So it really depends. But like if you have a stack now where you really want things to grow in size, linked list are preferred because you hardly need to iterate. The only like benefit of using an array is that like you get faster access. Like if you see now the peak operation now is just basically using the index to get the last item. But this, honestly, this thing is not really, is arguable because once we do linked list, you understand why. In a linked list now, like getting the first element or the last element in a linked list is also O of one because you store it in memory, like you store a pointer to it in memory. So I won't really say there's any, like, depends on how complex you want to make your stack. So linked lists are always preferred, but most of the time the stack really needs to grow and shrink in size. So on linked list, that's what they were made for compared to arrays. Okay, so again, stack is the last thing. First out data structure. All the operations have O of one. The operations being push, pop, pick, isEmpty, and size. While they are used, like there are many things that use stacks, mainly because they are using different algorithms, solving different problems. And they're also used to implement more complex data structures, like the stack memory in virtual memory now. Some browsers that may still be using stack to implement browser redo or undo. So that brings us to the end of my presentation. If you have any questions, please go ahead and ask.
Thank you very much, Mr. Ebube. I think Precious, I have a question. So Precious, you can go ahead and ask.
Okay, please, can you hear me? Can you hear me?
Yes, you can.
Thank you.
Okay, so I have a few to ask. The first one is, something like EU stack. So I'm not sure, maybe I missed the very first opening of your talk, but I don't think that's a naive question to ask, but I saw some EU stack as one of the classes of.
So your line is cracking. Is it just me? Like, please say it again, or maybe type it in the chat.
Stack.
Sorry, Precious, come again. Your line broke halfway through.
So it's on the message board.
Okay, the EU stack. So, son, are you asking
Yes.
like why I called it EU stack?
So I don't know what. So that's what I'm asking. Maybe I missed the earlier parts of. So
Okay, no.
what,
EU stands for Ebube Ugwu. I just didn't want, like, in Java now, like the name of a Java stack is also called stack. Like it's a import Java
okay.
dots. See, so Java has their own stack class. So
yes.
I didn't want to confuse it with my own. So I always append all the, like, if any DSA session you see me speak on, you always see EU in front of it. So it's clear that this one it's Ebube Ugwu stack. So I hope that answered your question.
Please. So this, I'm sorry, I have a lot of questions, but I'll just rush through them.
Okay,
let me also just ask: is there some reason why you created your own stack class entirely from scratch? Was it to show us?
Yes.
Do you understand what I mean?
Yeah, it was to show. Like, though actually, I did that a long time ago. You know, like if you are seeing the commit message now, you are seeing 2 months ago. Like I've implemented data structures before when I was practicing myself. I was like almost 2 years now. Then sometimes like I will try to do it again, like from scratch because if you don't do it, you forget. If you're not like constantly going back to do all these things, you forget. So it's just like for my own learning sake. But yes, it's always good to know how they work internally. You don't always have to like implement it yourself. But honestly, that's the best way to know how they work. So that was why I was doing the implementation.
Okay. Then I saw this also leads to my next question. So, so I'm not. Um, I would say that I'm still new in Java, so I don't really know my way around so much. I personally would have thought that since, I mean, most of us, okay, let me not speak for most people, since a good number of us are beginners, maybe I think that it would have been, probably would have benefited more from like applications of Stack, since we know that, okay, the thing I can always just do, like just declare or initialize a new stack. Then when I see a problem on Stack, like solve the few of them, maybe rather than the what's working under the hood, maybe like how to just understand the intuition of how the stack works. So I was a little confused at the beginning. I was just paying I was watching as if I have an exam this night. I really was just following everything because it just seemed new to me. I appreciate all the efforts too. Then I was also going to ask, I saw a problem you did on reverse. Can you hear me?
I can go on. I'm listening.
Yes, so I saw a problem you did that you reversed a string. And I was wondering why. So was that like just to show a use case for Stack? Or
Yes.
wasn't that like, okay, but that seems to be a question that would have been done without Stack. More,
Yeah,
like,
you can.
yeah. Okay, I just wanted to be sure. Then I also thought that would it be possible for us to at least, so I know that there are times that people have said that you could use primitive stack, maybe like an implementation of like, rather than your whole class, like use an integer array as a primitive stack. Would you just want to
there's no
touch that?
primitive stack. Yeah, primitive
By that I
data
mean
types.
that,
No shared stack.
no, what I mean is, like if you have an integer array, like int array, and you
Okay.
designate an index, like you call it top or something, and then as it moves, when you like the equivalent of pushing on your regular stack, you like plus plus top, and then when you pop, you decrement, that kind of thing.
So what was your question? Like, what was your question on this?
The question is, I was thinking that maybe we'll touch that kind of occasion where you want to use something that is not like a stack, but it works exactly as a stack, but like integer array. So sometimes when you see some of these questions and you are looking for a simpler and by that I mean that's something that a beginner can easily relate with, like more easily. I don't know if you understand what I'm saying. Like I saw the solution of string. Like if you leave me now, I understood what you did, but I don't think that if you leave me to it now, I will easily come up with the intuition. I don't know if you get what I'm saying.
I do.
Yeah, so something that I can easily remember because it is closer to my own lower level.
Okay,
yeah,
so
that's what I'm just trying to say.
Okay, so
Yeah.
this the cool thing
That's like
about
the
it.
sense of all my questions.
So I think I'll answer your question now with like I'll answer all your questions like now. So the thing is first of all, this session they are meant to be watched successively. Like there's a reason we upload every single thing to YouTube later on. If you watch the first ones, we talked about O of N arrays. The reason we're doing this in succession and building on each thing is that like because if the outline now builds on each one. The implementation I use now, here now, I'm using an array. We already covered arrays now, so there's no way I'm going to go back and start like showing you how arrays work because I believe that people who have come in to watch this session have already watched or already have an idea of all that we have covered before. Because it seems that there's only so much we can cover in 1 hour. If we make this in 2 hours long, most of us will get tired and bored. DSA is not interesting. It's interesting, but it's work. And secondly, there's no way you're going to fully understand unless you do it yourself. That's the simple truth. You can watch, even if you have professors come and teach you DSA, until you implement this in yourself, until you suffer and try to solve problems with it yourself. That's the only way you learn. Like, take it from me, I've watched so many DSA videos and the only time I truly understood was when I was doing it myself. Because once you try to do something and it's not working, you will now understand, okay, this is why they are doing it this way. Because you have felt the pain of it. It's only somebody that has written C or something like assembly now that will be thanking God for something like JavaScript or Java, because they understand why we have all these things in place. And yeah, so I think there's only so much you can cover in 1 hour. In showing your applications, or more, it really depends. Like I can't cover, it's not possible for me to cover every single use case. So what I tried to do was cover like popular questions you would see if you read all these DSA books, like popular questions or problems you try to solve using a stack. Another thing is that you ask like why I use the stack to reverse the string. Yeah, you're right. It's like it's not even efficient. Like that's not the most efficient way to reverse a string. You can easily do it in places in a for loop, and it should be O of n and O of 1 in space memory, O of n in runtime, and you'll be doing it in place. In fact, there's even an algorithm you can do to reverse a string and do it in O of log n. So, but I was just showing you there are many ways to solve the same thing. Why would you want to use the stack to reverse a string? Honestly, it's more elegant. If you have done recursion before, recursions are actually very inefficient. Most of the time, it is better, more efficient to solve a problem using a normal loop, not a recursion. But you still see recursions being used because it's an easier way for human beings to think about things. So I think it's more of an ergonomic feel, an ergonomic advantage over efficiency. Like see now in the string reverse, look how it's, I don't know, like when I look at this implementation, it feels sweet and clever. It's not efficient, but like you understand there are many ways to solve a problem. So this is just one of them. To me, I think it has a nice, elegant, clever, witty feeling compared to just iterating through it and reversing the index and then inserting each thing in place like you tend to do. Now that one feels very, very hacky. So yeah, there are many things, many ways to solve a problem. I'll just show you one application. And why I'll show you this is that stacks are very, very useful when you want to reverse something. With this now, anytime you have a problem you are solving, for instance, let's say you are writing React code now and you are getting you have a list of data now that you are fetching from one endpoint. And you're not thinking to yourself, okay, how do I now reverse this thing? Your mind will just come to this session now and you think, okay, let me try using a stack. Then later on, you can now refine that algorithm and use something else to try another way. So there are many use cases. Like I said, when you want to reverse something, think of using a stack. It's a very elegant way of doing it. It's not the most efficient, definitely, but it's a very nice and easy way to reason about. Then if you ever need to do an undo with your operation where you are just taking out the last item, like that's why you see it and we show it in the slide that stacks tend to be used for undo video operations. But very, very basic undo video operations, like nothing like what you have in text editors. Those ones don't use linear data structures. They use more advanced data structures. When it comes to nonlinear data structures like trees, we'll now see more ways that you can do something. So like there's only so much I can cover in an hour. The only way you really learn it and know it to your bones is by implementing things yourself and solving problems yourself. Yeah. So use cases, it really depends. Like when you have it, don't ask when do we use stacks. First of all, have a problem first, then ask yourself if you can use a stack. Because much of programming is thinking and trying different things, seeing what works. So nobody ever knows all the solutions. The point of being a programmer is learning how to solve problems on your own. So I will show you like the most common problems and the answers to those problems based on our own experience and what has been seen to work. It's always fun for you to try things differently. Even if there's already a more efficient solution that everybody already knows, you can always try a different way. And that's how you become good. That's how you discover things so that people don't discover by trying things yourself. So I hope I could at least answer your question and understand. Thank you.
Okay, thank you very much. next Saturday is the last Saturday of the month. So we'll be having Dashon come speak to us, come enlighten us on AI. I hope you're excited for that particular session. Dashon is going to, for those of us that don't know Dashon, some of the libraries that you'll be using on Spring Boot, it might likely be him that wrote that, you get. So yeah, he's going to be speaking to us on Saturday. Thank you very much, Mr. Ebube, for this wonderful, even though it's your background.